then submit it whenever it's done, but officially project 1 due April the 5th. Today we cover something called the capture-recapture method. At the end of today, a couple of things will happen. Number one, can you guys count real quick? How many sections of material are there that are on the test? All the stuff from there to there. Counting that day down to that day. There are 8 days, right? 8 sections of stuff. Okay. At the end of today, we will be halfway through the material for the second test, right? This is our 4th day since we had our first test. We spent 2 days talking about weighted voting. And last class, we talked about statistical studies. Today is day number 4 out of 8 in terms of the second test. Something else happens at the end of today. If we scroll down just a tiny bit, okay, how many classes are there? How many Tuesday, Thursday classes are there in the semester? Looks like 27. There's actually one more than that. Remember, we had the snow day, and so this has already changed. So there are normally 28 Tuesday, Thursday classes. This semester, there's only going to be 27. Today is day 14. We are halfway through the semester today, okay? In terms of Monday, Wednesday, Friday classes, I think tomorrow is the halfway point, but we're right in the middle. So hopefully we are surviving and thriving. So before we jump into the material again on page 18, I just wanted to show you a couple of things. Number one, just a reminder, Open Classroom Week is coming up. It is Monday through Friday of next week. Thursday of next week, there are no day classes. There are no evening classes. Thank you. Open Classroom Week, again, you can just go and sit in on a lot of different classes, see a lot of different kinds of subject matter, see a lot of different teachers, and really make an informed decision. My office is right around the corner, and one of my colleagues, Diane O'Hearn, anybody know Diane? She works in the advising center. She's great. So she's teaching a class, and she talked a little bit about Open Classroom Week, and my office is right next to the classroom she was in, so I could hear what she was saying, and she said it way better than I said it last time. So I'm just going to say what she said. If you go talk to some of my students from last semester, I guarantee you can find some students who will tell you, oh, Ian is the greatest person on the planet. If you can take a class with him, you should do it. And I also guarantee you could find somebody who says, oh my God, I'm so glad I'm done with him. He is horrible in every way. And neither one of those pieces of information is very helpful to you as you decide what teachers maybe you should take in the fall. You don't want other people to make the decisions for you. You now have an opportunity next week to see firsthand all the different teaching styles of a lot of different teachers here. And so take advantage of that opportunity. So that's coming up every day next week. You don't have to do anything to sign up. You just walk around and find the classrooms that you're interested in. There's a list of classes in the link that is in here. Okay. Any other questions about Open Classroom Week? There's the classes. Okay, and yes, summer and fall classes are up. They just went up, I think Wednesday afternoon, or maybe it was Tuesday afternoon. Yes, very recent. So if you want to see a list of all the classes being offered this summer and fall, go to the home page. At the top here, it says credit courses and programs, and then select the term that you're interested in looking at. So if you go into the fall, you'll have to do more work. You'll have to select a subject and times or days, whatever you want to do. But anyway, if you've been in there, it looks the same as it used to, okay? If you prefer a paper copy, they should be floating around campus very soon. I don't know when they'll be printed, but I'm expecting next week you'll see them all over the place. Okay, and then one other thing. A couple of folks in the questions of the day had mentioned to me that that the whole Shapley-Shubik and Bonds-Off stuff was just really, really tricky for them. And so I know that I've got my videos that I've been talking about up on YouTube, but I just decided to take a look and see if I could find the other people's videos talking about weighted voting theory. And if you just type in here, BANZHAF, remember that was the name of one of our power indices. The very first link here, I took a look at. I just skimmed it. I didn't watch the whole thing, but it seemed quite good. And so if you're interested in watching somebody else's take on the Bonds-Off Power Index, and you have 7 minutes, go to YouTube and just search Bonds-Off. And this guy right here, Hamblin Math, I don't know anything about him, but I do know that when I typed in Shapley, which was the other one. Okay, I don't know what the first thing is, but the second thing is something about the Shapley-Shubik Power Index, and in fact, it is by the same Hamblin math guy, and that one's only 4 minutes long. So 11 minutes, you can watch this person's take on those two, on the two concepts. So check it out if you want another resource. Questions on that? Okay, let's go to page 18, and we'll start at 1A. Linda? Mm-hmm. Okay, so there's a lot of n's in this problem, and it's quite difficult to think very generally about this. So maybe try plugging in specific numbers for n. Maybe answer the specific problem. How long would it take for a 1 mile long train going through a 1 mile long tunnel traveling 1 mile per minute? Answer that question. A whole lot easier than answering this. And then what's the next question you should think about? Yes. Yeah, so, but they're all the same n. So how about it's a 2 mile long train going through a 2 mile long tunnel traveling at 2 miles per minute, okay? And then maybe try one more, maybe try them all with 3s, and maybe at that point you feel comfortable answering this question, okay? So talk to your neighbors, we'll spend a few minutes. If you finish early, move on to part B on the next page. Okay, for question number 1, what did it turn out? How long did it take for that train to get all the way through the tunnel? It was 2 minutes, all the time. All the time is 2 minutes. Okay, this question is not a question you will ever see again. So what are you supposed to take from this question? I can give you a problem that seems very difficult, very general in the beginning. I'm fairly certain that nobody in the room on first reading that problem immediately said, oh, it's always 2 minutes. But by plugging in 1 for all the n's, you get an answer to this easier problem. And then you plug in 2's for all the n's, and you get the same answer to that easier problem. And then maybe we start to see the pattern. That's a lot of what math is. You try to answer something very general by looking at specific cases. So in this one, it was always 2 minutes. And not every group got up to the part B, the follow-up. So it's okay if you didn't, but we'll just let one of the groups talk to us about this one. Here it's still an n mile long train, and it is still an n mile long tunnel, but it's not going to speed up anymore. The train is always going to move a mile per minute. So it's going to take longer. If you make that tunnel big, it's going to take longer to get there because it's always chugging along at a mile per minute. Any group have an answer for how long it takes to do this? Jason?
Well, it's going to change depending on what you're plugging in.
Mm-hmm.
That's going to change. So we actually have a formula.
Yes?
The n times 2.
Yeah.
What do you got to?
Yeah, a few different groups talked about n times 2 is how long it takes to get through. So if n is 3, like a 3 mile long train, it will take 3 times 2, 6 minutes to get through. Okay, next thing I want to do, we'll look at 2. We'll go to Mary. Okay, so this is something you guys did at the end of last class. It starts on page 15. We're going to spend just a few minutes working through some of our answers. I want to make sure we can clarify and have a good sense of all this vocabulary. And in particular, I want to talk about the sampling frame because I think sampling frame is tricky. And I think it's not something I did justice to the other day. So I want to clarify to make sure we're solid on that concept of sampling frame. The sampling frame is the set of all the people that have a chance to be in the study, to be in the sample. So when I asked you guys on Tuesday, do you prefer day classes or evening classes? The sampling frame wasn't just the 23 people that were here on Tuesday, but was everybody who had a chance to be part of this survey. That is everybody who was in my 117 class, including the people who were absent. The sampling frame is everybody that is registered for my class because everybody had a chance to be part of that study. There were a few people who were absent and they didn't take the study. And so those few people were not in the sample. They weren't part of the actual survey. but they were in the sampling frame. So I'll say again, sampling frame is the set of all people who have a chance of being in the study. So for this example right here, this was about the how do undergrads feel about maybe canceling spring break week so that we can start summer vacation a week early. And we had 4 interviewers walking around at, it wasn't clear whether it was one school or a few different schools, but the sampling frame is the people who had a chance to be part of this study. The only people that had a chance to be part of the study are the people that were at the college or colleges where these interviewers were. And more than that, only the people that are at the college on that day, right? If you're a Tuesday, Thursday person and the interviewer comes in on a Monday, you have no chance of being in that study, right? You have no chance of being in the study. So only the people that get to school on that day. And even more, I'm imagining that this interviewer is just standing at the entrance to the main school building. The only way you're going to get a chance to be in the study is if you happen to be walking past that person at the entrance to the main school building when he happens to be there. And so we keep kind of getting narrower and narrower, and that's a dangerous thing. But the sampling frame is this really tiny set of people that had a chance to be in the survey. Now, how are you supposed to come up with all that from this very small description? You don't need to come up with everything I said. You just need to show me you are thinking about who has a chance of being in the survey. All right, so what I'd like to do is just look at a couple of different ones here. So we had the spring break one, and I think most groups were able to finish that one. And I think a lot of groups made good progress on the lottery one. And there are 3 other ones, I think, right? There's the yoga, and how does it affect your math score? And then there's breastfeeding and is it anxiety? And then the last one was red blood cell count and yeah, just a red blood cell count. Okay, so I would like to do one of those 3. Makes no difference to me which one we do. So I'm going to ask you guys to let me know not which one is your favorite. If we say which one is your favorite, what's the name of the voting method? If you only tell me your favorite, what is that called? That is plurality, where you just tell me your first choice. We have talked quite a bit about how the weaknesses of the plurality method. So we're going to do approval voting here. You can pick as many as you approve of. Your choices are, would you like us to go over this one about yoga and math, breastfeeding and anxiety, red blood cell count? Yeah, so, and it's okay if we do one that we haven't all had a chance to look at. Okay, but let's, anything you approve of. Raise your hand if you approve of the yoga and math one. 1, 2, 3. Raise your hand if you approve of the breastfeeding and anxiety one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Raise your hand if you approve of the red blood cell count example. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and most of you don't approve of anything. That's kind of a pessimistic attitude on life, but whatever. Let's try this last one here. Okay, so most of us have not had a chance to look at this, so we'll do it together. Can we get Charlie to read number 5? We're on page 17.
Red blood cell count is performed to evaluate any change in the number of blood cells in the blood, such as to diagnose anemia. Perform the test, the blood sample is drawn from a vein in the patient's arm. The sample is then sent to a laboratory where it tests the number of red blood cells present in a cubic centimeter of blood.
Okay, so let's see if we can answer some of the vocabulary here. We want the target population. Is the population big or small? Generally.
Big.
Population is big.
Really big.
What's the word for the small thing? Sample. Okay, population is big. You just study a small part of it, a sample. So the target population, you are trying to get information about blood. Which blood in your body? All the blood in your body, right? So the target population is all your blood. Well, this is one particular patient we're talking about. So one patient's blood, and we take a sample of that. Okay, part B, the parameter is the piece of information about the population that is being estimated. The parameter, let's see, so we're looking for the red blood cell count, right? It's how many red blood cells are in a cubic centimeter of blood. The parameter is something that is hardly ever known. Is there any way for us to go and poll every single undergrad and ask them about their spring break desires? No, it's not reasonable. So we can't know what percentage of all college students would like to get rid of spring break. We can estimate it by asking 400 of you. So the parameter isn't something I'm going to ask you for a number because that number is hardly ever known. But I will ask you to describe it. What is the parameter? What are we trying to find out about this blood? Is this phrase right here, number of red blood cells in a cubic centimeter of blood. Does that have a biology name? Like, is that the red blood cell count? I don't know. Is that right? No. I'll just copy that phrase, or at least tell you that that's the phrase that goes down here. Okay, I think this next one is the trickiest part, the sampling frame. It's the set of all things that have a chance to be in the sample. Maybe we could even jump down to the sample first, just so we're really clear. The sample is the actual people that were part of the study. In this case, it wasn't people. What was it? It's blood. And it's the actual blood that was drawn. So let's see, perform the test. A blood sample is drawn. Is the actual blood that was drawn. And so Johannes is saying maybe it's actually 1 cubic centimeter, like literally 1 cubic centimeter of blood is drawn. And in fact, you've heard the phrase blood sample before this, right? The word sample. You know the word sample. It means you take a small subset of the thing you're trying to study. It's the same word we are using here. In fact, or do we have like hip hop fans in the room? Have you seen the word sample, like from in a rap music context? What does it mean to sample? To take a part of somebody else's song. Maybe you got like the drum beat or some hook that you really like from somebody else's song, you bring it into your song, and then you make new stuff around that old thing. Are you taking a sample from somebody else's song? Yeah, you were taking a small part. It's the same idea. Like we use the word sample in a lot of different places. It's the same thing. You've seen this word before. Okay, coming back to part C, the sampling frame. It's the set of all things that had a chance to be in the sample. The set of all blood that had a chance to actually get drawn out in the vial that they took. Did every single blood cell in your body have a chance to get taken out at this one moment in time? So Charlie says yes. Why?
Because all the blood in your body had an opportunity to get drawn from the thing where they
Okay, so Charlie maybe knows some stuff about biology, and I will ask because I don't know. Does our blood circulate everywhere, like through every vein and artery and all that stuff? Practically. Okay, for all practical purposes, the blood that is currently in your foot, maybe yesterday was in your shoulder. Is that right? Could just go all over the place. Right. We are drawing at one moment in time when you're in the lab, we are drawing 1 cubic centimeter of blood from this vein in your arm. First of all, is there only one vein in your arm? No. So the vein that I hope nobody's queasy about like needles and stuff. Somebody actually last semester had to leave the room when we talked about this example. So the vein that happens to get picked by the nurse, right? That's the only vein that is going to have blood taken out of it. So any blood that is not in that one particular vein has no chance. So if you go to the lab right now, the blood that is in your foot has no chance of being in this sample. Agree? The blood that is in your chest and your stomach and everywhere else except for this one arm has no chance. Now I know that the blood that was in my foot yesterday might be right here in my arm today, but I'm not having this done all the time, every moment. I'm having it done one time when I go to the lab. The only blood that has a chance of being drawn is the blood that's in my arm, and more specifically, the blood that is in that one single vein out of the different veins that the nurse had to choose from. So I would say something like that for the sampling frame. The blood that is in the single vein in the single arm that is, I don't know what's the right word. Needled, poked, I don't know what is it? Drawn, that is drawn from. At the moment you have your test done. And that's not so great. Like, it would be better if instead of just having the one sample drawn from your one vein in your one arm at that one moment in time, if the nurse was willing to take, you know, a little bit of blood from your arm and a little bit from your right leg and a little bit from your left foot and just like take a little bit. I'm not saying like take like a gallon of your blood. Like, we don't need a lot. But really, like, if there's a problem with the blood in your foot at this moment in time, it's not going to be discovered when we take this little tiny amount of blood from this little tiny vein in this one arm in your body at that one moment. And so this is a weakness of like sampling blood like this. Now, if the blood circulates fast enough, like if the blood in my foot, when I started this example, is now in my arm, then there's a pretty good chance that we're not going to have, like if there's a problem somewhere, it will be detected because the blood just moves around all the time and it's quick enough. But if it's not, then this is a weakness. How about we look down here at E? Why would a survey be used in this situation rather than a census? Remember, a census is where you poll everybody in the population. A survey is where you just look at a small sample. Yes? Okay, so death is a bad reason. It's a good enough reason to not do a census in this case. If you were to draw every centimeter of blood from a person, you would get the most complete health profile you could of that person's blood, right? You'd have complete information, but the cost would be kind of high, right? Okay, and then the sampling method. All right, we have different choices here. We have a convenience sample, we have stratified sample, we have quota sample, we have simple random sample. Is it a quota or a stratified thing where it's like broken up into categories? We make sure we have at least this many people with brown hair. No, okay, so it's not either of those. So the only two options left are convenient sampling and simple random sampling. I think you can make an argument for either one. If you believe that the blood that is in that one vein in your one arm at that one moment in time is a random sample of the blood in your body, then you could call it simple random sampling. But if you think that this is just a matter of convenience, that we're doing just this one vein in this one arm because it is more convenient than what I proposed, where you get stuck in 10 different places at this one blood test, then it's convenient sampling. I kind of feel like it's a convenience thing. But if you justify your answer, it's possible that we'll get full credit for more than one answer down there. If the blood in your body is like circulating all the time and the blood in my foot 5 seconds ago is now in my arm, then I feel like every like drop of blood has a pretty like an equal chance of being right here at this moment. And so if I feel like it's really, really random, what blood I'm getting right here, right now, then I could say it's like a simple random sampling. I kind of feel like it's more of a convenience thing. Oh yeah, no, we're just looking, well, you're answering like a different kind of setup. If we had a lot of people to choose from, then maybe we randomly picked a person. But here it's one person, and we're deciding whether we're randomly picking their blood. Okay, any other questions or comments about this one? Okay, so let's go to the next page. I think we're at, oh, what did we forget? Oh, biases, yes. Any possible sources of bias or error? We have named a few already. If the blood in your arm is not representative of all the blood in your body, that's a kind of error. Let's see, what was the name of? What's that? Oh, if the blood in your arm is not representative of all the blood in your body, then this is a kind of bias. It was selection bias is what we had called it the other day. Possible sources of error, you can make stuff up. If you had something that was very rich in iron, does iron affect your red blood cell count? Again, this is biology that I don't really know, and if you happen to know it, then great. But if you ate something that was very rich in iron 5 minutes before you took this test, perhaps the results would be skewed, right? It would not be representative because you have done something external that changes the results for a short period of time. So maybe there's medication that is changed, that has temporarily changed what your real red blood cell count is. Okay. All right, so let's come down here, back on page 19, and we'll go to number 3. And where are we now? Can we go to Johannes? 3 on page 19. Okay, so we're going to describe a method that actually a lot of naturalists end up using to count things that are really hard to count. Why is it hard to count all the elephants that are in the Serengeti? Okay, you'd have to round them all up. The Serengeti, it's an enormous space. Elephants probably aren't going to say, okay, let's all go over here in this one little corner of the Serengeti so we can get counted. So they're all over and they're constantly roaming around. Very difficult to actually get an exact head count of these elephants. So we're going to do something easier, and we're going to hope that what we do is mathematically sound and will be able to give us a good estimate. We'll go to Kelly, the idea. Keep going. Okay, so we're going to go out and capture, say, 20 different elephants in the Serengeti. Doesn't matter which ones. You just capture 20 of them. Then you put a little tag on them. Hopefully we don't hurt these elephants while we do it. But we make it so that we know which 20 we have captured. Okay, let's go to Iris for step 2. Okay, so we grabbed 20 elephants, we marked them. We then let them go back into the Serengeti and we let them mingle and merge with all the elephants there so they're kind of mixed up. Then we go out and we grab, say, 30 elephants. Now, some of these elephants that we grabbed probably have tags on them, right? It could be that we grab some of the elephants again, and also some of the elephants that we grab we've never seen before. So out of the 30 elephants we just grabbed, some of them will have little tags on them. And so the idea here is that we're going to use like fractions. We're going to use proportions to try to estimate the size of the population. Suppose that this is what happens. 20 elephants are tagged. That's the original. You don't need to write this down. This is me trying to like justify this formula down at the bottom here. Suppose that 20 elephants are tagged, and then we release them, and then we go out and we capture 30 elephants. And suppose that out of the 30 elephants that we capture, 15 are tagged. That is to say, half of the elephants that we grabbed already had tags on them, right? Tell me if you think this is reasonable. Perhaps half of the elephants in the whole field have tags on them. You grabbed 30, that was not all the elephants, but half of the ones that you grabbed had tags on them. So maybe half of all the elephants, including the ones I can't see, have tags on them. Can we buy that? Yeah, I mean, numbers are potentially big. This is not the Serengeti. This is a small little field. Yeah, okay, so right now we're just like in the cafeteria downstairs. We just got some elephants, but we can't count them all. So, okay, so again, you tag some elephants, you let them mingle, you go out and you grab some more elephants, and half of them are tagged. Well, maybe, just maybe, about half of all the elephants were tagged. And if half of all the elephants were tagged, and you know that there are 20 elephants that you tagged, definitely, then how many elephants are in that room? There are 40 in the room. We buy that? If you figure that maybe half of all the elephants are tagged because of what you found here, but you know that there are 20 tagged elephants somewhere out there, then maybe that 20 is half of all the elephants. maybe there are 40 elephants in the room. That's the heart of this method. So, no? The other 15, which other? Right. Right.
So there has to be at least the other 15, 5 that were already tagged.
Now, what are we saying? So there's 15 tagged elephants here.
Okay, so you tagged 20 original.
Yes.
And then you go out and you find 30 more. 15 of those are tagged.
Yes.
And then, so that means that 15 were untagged.
Yes.
So you're assuming that there's 35 elephants?
Yeah, I think
the assumption, but even that, it just seems like this.
It's an estimate. It's an estimate. But even before we get into the how good is this estimate even going to be, I'm hoping we can get at least a bunch of you guys on board with this idea. So we'll say it one more time. We're just going to do an example. I actually brought some little mini elephants in the room for us to try. But again, the idea is you grab some elephants, you tag them, you let them mingle. You then grab some more elephants. Now, some of the ones you grabbed the second time, you'd already seen. You have already tagged them. And you know how many you tagged because you can look at them. And if half of the elephants that you grabbed the second time happened to be tagged, then perhaps half of all the elephants in the field, including the ones that you cannot see, are tagged, roughly. And so if half of all of the elephants are tagged, and I know that there are 20 elephants out there with tags on them, then maybe that 20 is really half of the total population. It's really half of the 40 elephants that are out there. So when all is said and done, ultimately, I'm really hoping that you guys will buy into something like, I'm hoping most of you will buy into something like those fractions equal each other. Certain number of elephants tagged out of the total, which is unknown, compared to the same kind of ratio, number of tagged divided by the total. That's all that's going on down here in this step 3, this used proportions idea. So let's give it a shot. Okay, in this jar right here, I have a bunch of white elephants. I know exactly how many white elephants are in this jar because I counted them this morning. That was a lot of fun. So here's what we're going to do. What's the first step? We're going to capture some number of elephants. I'm just going to reach in and grab a handful and we'll do 2 more. Could you guys just real quick count those for us? What do we do with these captured elephants? We tag them. Now it turns out when you capture a white elephant, it turns color. You know what color it turns? It turns red. It gets kind of angry that it's captured. So red is the color of anger. So what are we going to do? We're going to find out how many are there, and we're going to tag them, and we're just going to put them back, but we're going to make them red, okay? Can you guys group those in 5s or something? How many? To use your imagination. How many is it? 25. Can you guys find 25 of these for me? Can you find 21 of these for me? I didn't know this was the hard part, but apparently 25. Can you guys find 25? Yes. Let's put them back in the population. Okay. However many marbles, however many beads are in here now, it's the same as how many were in there at the start, right? All I've done is I've got 25 of these guys out here. I've replaced them with 25 reds. Still the same, all right? The red ones are which ones? They are the tagged ones. They're the first capture. Now what are we going to do? What should we do with this thing, like physically? We should mix it up. Because if you got all the red ones on top, and I ask you to just grab a bunch of them, you're going to get more reds than you probably should. So we're going to mix this thing up. And then we're going to ask everybody to pick 1 marble out of here without looking in. Grab 1. Don't look at it even after it's in your hand. Grab 1, pass the jar. Can somebody, while we're doing this, can we get a few people to count how many students are in the room? because this is how many elephants we are recapturing. Just grab one, pass it around. Okay. While we are waiting, can we start the calculations here? Let's begin over here. All right. Let's come over here. The left-hand side is the first capture. How many elephants were tagged? It was 25. Out of the total, I don't know, X, is roughly equal to. Okay, we are currently doing the recapture, so we don't know these numbers, but I do know that however many we end up getting tagged divided by however many we pull total is supposed to go there. It was 25 tagged over X total compared to same kind of ratio. We do know how many we're about to pull out. How many total are we about to pull out? Anybody count the students? Was it 25? There are 25 people in this room? 24 students. Yes? Wait, why is counting in small is counting should be easier than this. 4, 8, 13, 16, 19. I got 23. Am I right? We need more people to. No, don't trust me. Look around.
You get the vantage point.
Oh, 24. I missed Emma. She's ducking down and hidden behind. Okay, 24. Where does the 24 go over here? 24 is the total number of elephants that we are about to grab. 24. Okay. Does everybody have one? Everybody has one? Okay. Now look at your hand. If you have a tagged elephant, stand up. If you have a red elephant, stand up. Okay, all the reds are up. We have 4. Where does that 4 go? Right on top. We captured 24. 4 of them were tagged. 4 of them were ones that we had seen already. 4 of them were in this original group of 25 that we grabbed and then replaced with reds. This is the proportion we're going to solve. A little bit of algebra that we have to do. You guys remember cross multiplying? So cross multiply. So let's see. So we cross multiply here. We get 25 times 24 is equal to 4 times x. And then do a little bit of work with your table mates to solve that equation for x. So I had a few folks saying 150. I need you to be able to do that kind of thing on a test. Any questions about the algebra that we just did? We're doing very little algebra this semester, but I need you to be able to do this. Any questions about the cross multiplying? Okay, what is this 150 representing? Yeah, total. That's the total that we had here on the bottom. The total number of beads that were originally in that jar. Okay, what would you like to know right now? How many beads? I counted. I literally counted one at a time this morning. Now, I have not touched this thing since we started this experiment, right? I wrote down how many beads were here before we started. Nice and loud.
146.